This is Jaehong. I'm a team leader for Boeing Capstone project. In this sprint, I was mainly reviewing the code base that we made last semester, thinking about what improvements that we can make in terms of performance rate and the accuracy. And one idea feature that I can add was to implement the semantic search, which is fetching the most relevant information in the document based on the cosine similarity. But before that, there are some preliminary steps that needs to be done, which I'm going to show you. First, once we upload the Boeing document, which as an example I'm going to show is 86 page long, which explains about the pilot operating manual. And so if we go to the parse.py, it will parse the whole document, not only just page by page, but also within each page, it will parse it line by line as well, which will store as a list of sentences and in JSON format. So as an example, this is representative of the Boeing document pilot operating manual, and it also says about how many pages there are in total, and also the pages field, which is a list of dictionaries, and each dictionary is representing the page information, including its page number and the sentences. I also make sure to parse line by line so that it will facilitate for retrieval based approach that I'm going to show you in semantic search. And now we parse the document. The next step is to generate embeddings for each sentence. And that embeddings is a vector representations of each sentence that will be compared against the user query to find the most relevant and that shows the highest level of similarity. So this is how it looks like. And if we go to the embedding.py, we're going to use the Python API that will get the sentence and will spit out its embeddings, which is generated by the API. And let me run the script. Let's wait for a while. Now it's showing the progress bar. Once they're done, I can show you how it looks like in .json format. So now, as you see, now we have a huge long list, as you see here, more than 200 thousands of lines of long. And what we see here, the main difference that we can notice is the rest of the information is the same. The only difference that we have is we have a new field called embeddings, which is a list of lists. Why is that a list of lists? Since each sentence can be represented as a vector, we need to represent vectors in a list of the floating point numbers you see here. And so this huge list as the first element of the list is to represent this first sentence, explain Boeing. And now we're all set for performing semantic search. And this is the script that I'm going to run. So based on the generated embeddings, it will let users enter their query. Let's just as testing to show it works, I'm going to use the auto throttles. What is auto throttles? So now it will spit out its most relevant information, including its page number for user reference. So it says that this switch is used in conjunction with blah blah blah, and page number. Let's go to page number 49 to verify that. So this is page 49. We're going to see the auto throttle here in section 2. we have auto throttle. This switch is used in conjunction with DIS, which corresponds to the information presented on the VS Code. And also, we all saw that this information can also be found in page number 51. And so, so we can see the auto throttles was mentioned in when we're explaining N1 but so oh not this one. The information here is not fully explaining what auto throttle means, but the reason why it's mentioned here is was the fact that the term was used in explaining other operating manual terms such as N1 button. So this may be our next step for thinking about what are some ways to printing out only the information that's strictly explaining the definitions of auto throttles. And so the next feature that I'm going to show you is the extractive summarization feature based on the retrieval-based approach. And unlike last semester I used a pre-trained model from Hugging Face, which basically is fit in with the input data and it will take time to process its input and generate its summary response. And this time I decided to use based on the embeddings information that are present in the JSON file. And as you will see, it showed huge improvements in terms of time performance. So let's run the script. So yeah, it's going to take some time. And the first result that we see is the one that uses the pre-trained model from Hugging Face. I make sure to log the time to objectively measure its performance. And as you see here, like this is the page original text that will be used, and it took like more than 4 seconds, which I would say huge latency. But what about when we use the extractive summary? It took only about like 0.004 seconds, which I would say huge improvement compared to the more than 4 seconds one. So this is the one that uses the summarization based on the vector search, and another one uses the same kind of summary, extractive summary, but it uses the k-means clustering. Even though there's a little bit of overhead compared to the second case, but also I would say it's still pretty fast performance. And also I asked ChatGPT, prompted the original text to see how accurate the summary is in terms of the accuracy and the line coverage. And this was a response that was able to get. Um, the summary model, the first section is the one that uses the pre-trained model. It shows 35% of line coverage and along with almost close to 90% of accuracy. For the second one, which is the extractive summary, which took less than 0.1 seconds, even though there was a bit of decrease in terms of line coverage, but it achieves slightly better, more accuracy. So I would say this is a huge gain because I was able to make a huge improvements for the performance wise. The last feature that I want to show you is the translation model that uses the better one in terms of accuracy. And oh, before that, I want to go show you in mongo.py. This is a Python script that connects the Python to the MongoDB. So what it will do, once you run the program, it will create a users, which and then make able to connect to the MongoDB using this URI. It will fetch the credentials that I stored in .env file since they're highly sensitive informations, and and then we can also verify that here, if we go to all clusters, jhong collections, and it retrieves a list of database. If we go to inside of the Boeing document database, we can see the collections which is the same representations that I showed you as in JSON format earlier. So we have an array of 86 elements since there are 86 pages. For each page, we have page numbers, sentences, and embeddings. An array, which is all the same information that I showed you in the beginning of this video. And now let's move on to the introducing the translation feature. And this time it uses the model called Facebook from Meta. So this is a multilingual translation model by Meta. And I found this model to be working more accurately compared to the last time. And last time, as we all know, it achieves, depending on the language choice, obviously, but for some of the choices, like it achieves like almost zero accuracy. So the work was pretty much meaningless. And for example, English to Korean translation model it achieves 0% of accuracy. As you see, the same words that are repeatedly being used over and over, meaningless text, completely irrelevant to the input data. So I was looking for other models that may generate better translation. So this was the one that I found. So now let's run this script. So this will fetch the data from page number 8 from the Boeing document, translated line by line. So now it's showing the first sentences and its translation version. If we hit enter, the second sentence and the followed by its translated version. Yeah, so as you see here on the surface level, you can definitely notice that they're not using the same words over and over. And also you can see a more variety of words that are being used for translation. I can also verify that this translation is much more accurate. And although like as we get to the end of sentences, like the translation is getting much less accurate, but I think part of it has to do with the fact that this is not in the form of complete sentences. Uh, and also to objectively verify how accurate and how improvements has made compared to the last time, I also prompted the original text, input text to the ChatGPT, and this was the response that the ChatGPT showed. So according to the ChatGPT, the overall accuracy achieved was around 66%. So 66%, although it's not perfect, but it's a huge improvement jump over from the zero accuracy last semester. Yeah, so far in this sprint video, these were all the features that I implemented. And yeah, thank you.